Thank you guys for having me. It's great to be here. My name is Elliot Dauber. I graduated from Stanford in June. I did 5 years there and got my bachelor's and master's in computer science. Um, I was previously at Humane before this, which was really fun, but I was doing completely different work. I was working mostly in Java. We were building on top of Android, nothing to do with JavaScript or TypeScript. Um, and I just joined about 2 months ago as a founding engineer at Markprompt with Michael Marie, who is here. Um, and I have, a disclaimer, I have written some JavaScript. I had not really written much TypeScript before this, but I have played around with JavaScript and I kind of shied away from it because anytime I built something reasonably large, it just became a huge mess. And one of the reasons that I was, I think, attracted to Markprompt was also because they were focused on really building robust systems and not just hacking together a product to follow the hype, but we are really here for building things for the long term and doing it right, which is, I'm young, I'm in my early 20s. This is what I want to learn as an engineer. Um, and yeah, I'm a complete effect beginner. I didn't have the burden of like introducing effect into our ecosystem or choosing effect, but Michael had already chosen to use this as our core technology, and I kind of jumped in and had to learn it really fast. I also played a lot of music in school, and I love to travel. Um, so Markprompt, we're building AI infrastructure for customer support, which has been really fun. We were working very, very closely with customers, mostly in enterprise and high growth companies. So these are customers that demand a lot, and we're moving very, very fast, and we need to be able to do that in a safe way. We are constantly iterating on things. We are constantly working with customers to integrate what they need, and that is, in my experience with JavaScript and probably TypeScript, not something you can do in a very good way if you don't have something like effect to keep your code base maintainable and keep complexity down. Um, and yeah, we work in a TypeScript monorepo, and we use effect throughout. I think it was originally built without effect, and we're migrating everything basically to effect. But that's the overview of our stack. Like I said, the reason why we chose to use effect is because we need to be building these robust systems, and we are building them specifically on top of very unreliable systems. Um, I'm also going to be talking a little bit about AI. If I had known about these packages had come out a couple months before, we probably could have saved some work. But this actually seems like really great stuff for us to be able to kind of like just take out our custom implementation of a lot of this stuff and use the effect stuff, which is another thing that I think is really great about effect is that there's just every time you want to reach for something, there's something there that will solve your problem, and it's all native to the same library, so it all just works really well together. So this is a graph of the OpenAI uptime in the last 90 days. It's like pretty good. Most of the time it works, but it does go down every so often, and that means that we also will go down if we're not handling these things correctly. There are other model providers, which I'll talk about, Anthropic, stuff like that. But we need a way to fall back gracefully to those things and not be at the whims of these really unreliable systems. So yeah, some common problems. Sometimes OpenAI, their API just goes down. They have an unreliable time component, which is something else that Effect is really, really great at helping with, like with the timeouts that Maxwell was sharing. And sometimes the APIs just like don't work that well. Like you make a tool call and the parameters that come back are not what you expected, and you need graceful ways to handle those kinds of things. Um, so how Effect is helping us, extremely simple fallback and retry logic, easy concurrency, explicit errors. I think these are all things that you guys, if you've used Effect, you know about. Very powerful streaming support. One of my favorite things is the dependency injection framework. It is just so nice, both for production services, which I'll get into, and also for like mocking and testing things at every layer. It's just so nice. Observability, of course. So I'm going to talk about some of the cool things we've done with Effect at Markprompt, share the reasons I really enjoy working with Effect, and then reflect on some of the lessons I've learned using Effect and some of the things that I think you need to be careful with. So yeah, first of all, I'm going to talk about our LLM interface. So this is not, the point of this is not really to like understand a lot about AI. It's really to understand how we deal with the uncertainty of these model providers. And so we have some generic service. We can get chat completions from it, like from OpenAI, or we can stream them, and we create an effect service. Pretty simple. So we can treat this like a black box, actually very similar to what Maxwell was saying. You just pass in your parameters and you get some output, and you don't really care what happened in the middle. And so if you want to create a chat completion service for a single model, you pull in your model providers from the context. Oops. If it's an OpenAI model, you use your OpenAI completions, and if it's an Anthropic model, you use your Anthropic completions, just using schema matching on these strings. Same for Grok, anything. And so your black box becomes just this single chat completion for this model. And where stuff starts to get interesting is where we start to be able to actually do fallback and retry. And I think a good disclaimer is a lot of this stuff Ethan helped me with a lot, and also Michael. So this is not all stuff that I've come up with in my own brain, but okay, so what if we want to say, okay, I want to make a request to OpenAI, but I want to fall back to Anthropic if there's some failure in the OpenAI API. So use this ref, another really nice thing. Almost every piece of code I'm sharing here is effect native, which is really, really nice. So we say, okay, when we call this get chat completions in our service, we check if the primary has already failed. If it hasn't, then we just get the primary services completions, so OpenAI completions. We add the retry policy, and if that actually fails, this third block here with the effect.gen in the most inner block is the failure state. We update the ref, say that it has failed, and then we just use the secondary check completion. Very, very easy retry. You can use any retry policy, and then you have a fallback. And then if you've already failed, this ref state stays. If you've already failed, then you just use the secondary. And so all of this, and yeah, this is exactly the same for streaming. All of this stuff gets bundled into this black box, and you can start building these primitives to handle all of this stuff in a really, really graceful way. And it becomes really, really fun to build these things. So you have your retry policy, have some default retry here. We're just composing these fallback and retry with this retry policy. And then you say, okay, I want to use GPT-4o Mini and I want to fall back to Claude. And if you'll notice here, these things start to be very, very composable. So you can just say, oh, so this is an example of that. Then you start to be able to just nest these things. And this is like a very common functional programming style of just being able to have these primitives and just build things up in a really, really, really simple way. And it becomes so readable. Like you read this and it's so obvious what is happening. And so you get to start to build these things up. If things fail, internally, we just keep that state. It's a very small amount of state. And we can just start to build these really powerful things. So that leads me to testing. So we want to be able to model the failure state of these providers so that we can write end-to-end integration tests. So if these things fail, we know what our system is going to look like. And this is where I love the dependency injection framework in effect. It is so, so powerful to be able to model very, very fine-grained error states. And also higher level error states. And you can provide these things at the top level of your program, and you don't clutter the inners of your program. You just decide, okay, I'm writing an integration test. So we have a live fetch service that just makes the request, and then we also have an always 500 service, and this just will throw a 500 error. You could also write one that just responds with any text response. And so this is some code from our integration test suite. We just say, okay, if the test name is OpenAI completions down, we just provide the actual OpenAI completion service with a faulty fetch service. So we just provide the error state of this. And we could provide a OpenAI service with an actual like OpenAI error. You could provide any type of service to this. And this is the really, really nice thing is that like all of this stuff happens at the top level of your program, and you don't have to worry about like all this like testing code within your program. You just have these really nice interfaces, and you get to just build things the way you want them, and then kind of separate the testing out, which is so nice for building these robust systems. Again, yeah, OpenAI completion's down, you just provide. And so you can say, okay, so say we have like some API route, and we do a lot of stuff with, excuse me, um, with LLMs. We do post-processing on our data with LLMs to generate, sentiment analysis of a conversation that a customer has. And you can just provide this faulty OpenAI service to the entire system, right? And you don't have to worry about it anywhere else. You just know anywhere where you call this, it's going to throw an error, and you can make sure in your integration tests that you have the right behavior. Really quickly, also just so nice that Effect has all of this streaming capability. So say we make a streaming request to OpenAI, it comes back. This is a beautiful, I didn't write this code, but this is like a very beautiful thing you can do with Effect, is just split the stream and just say, I want 2 copies of the stream. One is just going to go directly to the user, and one is going to go to our analytics endpoint to actually like do some, like I said, that sentiment analysis and store these messages in the database and stuff like that. And so we were actually having an issue where um, the uh, the user stream was ending early because, sorry, the side of the stream that went to the user was ending before the side of the stream, since these things are happening concurrently, are before the database call was made, and so our messages weren't getting stored. And we're trying to figure out like how can we, and Ethan helped with this one as well, how can we actually like just ensure that the database call has completed before we close the user stream, so basically our serverless function doesn't end. And normally, if you're not using Effect, you have to go out and reach for some other library or deal with state yourself. But Effect just provides a really nice way. This is what I love, is that there's just always something that you can pull in. And maybe if you guys know more Effect about me, some of this code isn't right, but I think it is. Um, but I'm hoping this is right. You can just say, okay, when the stream ends, I want to set this deferred to true. We're done. And then the other side of the stream, the user stream, we just waits for that. And you don't have to deal with other concurrency libraries. You can just deal with this all in Effect. Really quickly, also structured outputs. This is a huge thing with AI right now, is being able to do tool calls and structured outputs, basically asking for a specific like JSON format back from an AI provider. And so we have this chat completion service, again, like kind of a black box. Say we are asking a prompt, your task is to read a customer conversation between a customer support agent and a customer and give a score to the agent on how well they answer the question. So this is part of our evaluation suite. We can just build this very easily with Effect. Just give it a schema, like an Effect schema. Just say I want the score and rationale. Again, provide this kind of opaque service to it. And your output is just nicely typed. And that is such a beautiful way to interact with LLMs, because you just ask it for some object and you just get that. And it's such a nice abstraction. And again, all of this is just completely in Effect native. And so everything fits together really well. So again, we have this service, and say we're building like an agentic workflow like Max is talking about. So going from just doing RAG when a customer asks a question, but actually doing multiple steps, maybe extracting feedback from previous runs, and maybe want to do these things in parallel. Again, Effect has something very easy for that. Say we want to do something more. This is a kind of like the classic React think, act, observe pattern, where we actually maybe want to like do some looping with Effect, or sorry, with our AI calls, and feed their input back into each other. Maybe we want to concurrently do something else. The steps here aren't that important. The point is things get really complicated really fast. And having, maybe the action step is actually a structured output. It's more like a tool call. And having these services that we can provide to different steps of the workflow is really great. So say we have this generic OpenAI to Anthropic fallback that we want for that's our default service that we're going to provide, and then at each different step, maybe there's a different model that's better for structured outputs. Something new comes out, we just very easily, few lines of code, provide that service, and nothing else in our program changes. We just provide it to that function that does that part. And say there's a model that comes out that's really good at, I don't know, reflecting. We just do the same thing. And so this stuff becomes so simple. And when you build stuff in Effect, I think what's really nice is it is harder at the beginning, but the changes that you have to make to your system when you want to do new things are just so much easier, which I think is so powerful for us when we're trying to move fast and a customer asks for something or some new technology comes out because this stuff is moving so fast. To just be able to plug that in it's so powerful. Um, so that's kind of the end of the code section of my talk, talking about what we've done. I'm going to give some reflections, and then I'm happy to take questions. So again, like I've been talking about this whole time, I think the reason that I've really enjoyed working with Effect and it's so fun is because it's composable. This is what we do as engineers, is we build systems that we can piece together and be creative, and it gives us the tools to be confident when we're being creative and not be afraid that every change that we make is gonna just like completely break our system. It drives us towards a functional programming style. This is something that I think everybody like in the back of their head wants to be able to write their code in functional languages, but you just can't because there's not the ecosystems. But when you have Effect and you're writing in TypeScript, being able to leverage that ecosystem and pull in things when you need them, but still be in TypeScript and writing in this functional way is really, it's just fun. It's very aesthetic. There's so much stuff going on in Effect that I have not even touched, which is really fun because you show up to work and there's problems you have to solve and you don't really know what to do, but you just like, there's definitely something. And they're building this new AI stuff, and there's always going to be new stuff coming out, and it is sometimes hard to piece through the documentation, but the stuff you're looking for is there. You just have to be curious and go find it. And this is really, really important. We're a very small team right now, but as the team and systems grow, you can have people working on different subsystems and be sure. I haven't even talked that much about error handling, but you can be sure that when somebody is building or changing a subsystem and you want to integrate it, that you know what is happening there, and it's not just going to throw a bunch of errors. You get these really nice contracts between the pieces of your system, and it just allows you to do more engineering and do less communicating, which is really, really fun. And dependency management is the same thing. Some lessons I think through Effect, it's definitely not a silver bullet. I think when I joined, there's like a lot of hype around, oh, we're using Effect, we're building this like really, this is what you do, this is how you build a reliable system, just use Effect and things are going to work. I think that was more of the mindset that I brought to it. But things can go wrong and you need to use your brain. You need to be smart about what you're doing. And so example is, I think it's really easy to write the happy path code in Effect. That's what it's built for. It's built to keep track of the errors so you don't need to if you don't want to at that certain point, but are forced to later. But when you're looking at Effect code, because of that, you're not always able to see what can throw errors. This is true in TypeScript and JavaScript too, but I think with Effect, when you have that thing in the back of your mind that you're like, oh, I'm using Effect, I don't have to think about this as much, I think that can also definitely be a bad thing. So for example, if you have an API handler and you just put a catch-all at the top, and you have some, I mean, as a beginner in Effect, I think probably most of you who use it are like, this is fucking stupid, I would never do that. But as a beginner, I was like, yeah, I want my code to compile. And I think like say you introduce some new error type, some custom error, and deep inside your API handler, you throw that error. You at the boundaries of your Effect code, errors still exist, right? And so your customers are still going to see this error, right? Because you're throwing a 500 from your API. So obviously the right thing to do is to catch specific tags and not use a catch-all. And then you get this really nice error message, pretty nice error message from Effect, and you can handle that by obviously putting a handler for that error and making sure that you handle that explicitly. But I think also more nuanced things come up where, say, you add some other function to your API handler, and deep inside of that function, you also throw this error. But your intent was that in some other function, you were going to handle that error and recover from it gracefully and do something else. Maybe do the retry that we were talking about before. Um, uh, but because you're handling this higher up, you don't get any warnings from effect. Um, and so these are the kinds of things where you need to really be paying attention. Um, and it isn't like, oh, you just use effect and you don't have errors, right? Like you still need to be very, very smart about what you're building. Sometimes it can be very hard to track down where services are provided. I think this is a really nice thing with effect is that once you write the code, and especially when you're the one who writes it, you're like, ah, this is so beautiful. And then sometimes somebody else comes and reads your code. I'm usually that person, and I'm just like, what in the world is going on? And I think that this sometimes can be solved with documentation and proper naming and organization of your code. But I think this is something that um, I've found hard learning effect is that it's not always clear where things are being provided. Tracking things down is hard. I think it is still better than the alternative, but it is, I think coming into it new can be a little bit confusing. There's so many ways to do things in effect, which is a positive, but also working on a team of people, you're going to see so many different styles, and it might not be the style that you would have written things in, and so that can also be confusing. I think also the fact that there's so many APIs in effect, there's so many functions, it can be overwhelming to figure out where to start. But I think the flip side of that is there is always something like I'm showing in this code. All of it is effect native. There's always something, but I think it can be tough to figure out and overwhelming in the beginning to figure out what to reach for. Another really nice thing is you can incrementally adopt effect, especially like if you have one API route. Like one backend route that you want to make more robust, you can just implement it along that route. I think you get way more benefit when you, obviously with the dependency injection and the error management and stuff, when you do things all like as deep as possible, right? Because otherwise at the boundaries of your effect code, you lose a lot of that. But I think that effect is great because you don't have to just like spend 2 weeks like migrating your code base. You can do it slowly and figure out what works for you. Use the pieces that you want, and then the full benefit does really come from full adoption. So I just want to end on this. I think effect has been a joy to learn and work with. It just makes sense. I think as engineers, it lets us focus. It gives us the tools and to focus on like really building systems in a creative and fun and correct way. And I think you have to want to do that, and you have to be curious and want to learn. But when you start to move things over, it is way, way more rewarding to build these things in a way that you are confident about. And I think also to answer one of the questions that was asked earlier about kind of like prototyping with effect and how that feels hard and there's friction, I think that I actually disagree a bit. I think that the power, if you just start using effect and you start prototyping an effect, when you're prototyping, you're a lot of the times, especially when I'm prototyping with AI and stuff like this, I'm stealing so many errors and I'm not actually building the stuff that I want. I'm like spending half the time debugging, right? And I think if you can start using effect at the beginning and actually just start to build your things with this, you actually save yourself a huge amount of time, and I get to actually do the things that you want to do, which is the building and not the debugging. So yeah, thank you guys for having me. This has been great. I hope that I hope you learned something. If you're new to effect or thinking about adopting effect, I'd highly recommend looking into it. We are hiring at Markprompt. Quick shout out. We're hiring another founding engineer and a founding go-to-market position. So if you're interested, or anybody else here is interested, or anybody else you know might be interested, please come talk to me after. And Michael and Maria are here as well. We're building a really, really fun team, building great systems, and this is my contact info. So yeah, thank you guys for having me. This has been great. Appreciate it.